Participant, please just spare 5 minutes. There is some technical issue with the resource person. We are going to start the program shortly.
Am I audible? Hello.
Yes, sir, you are audible, sir.
Yeah, thank you very much, ma'am. Can we start with the presentation?
Sir, before going to for your presentation, Shanti ma'am will be guiding you. Then it will be followed by your brief introduction. Then we'll be introducing you, sir. Then you can start your presentation.
Okay, ma'am. Thank you. Thank you.
Shanti ma'am.
Ma'am, I think we are already late. Let's don't go like this. We should directly start the presentation.
Okay,
I
sir.
think,
I'll be
yeah, I think she is logged out.
Sir, I'll be starting with your brief introduction, sir. Then you can
Okay.
start it.
Okay, ma'am, fine.
Good evening, all. I, Koti Tejasvi from Department of CSE would like to introduce you all today's resource person, Dr. Rajesh Kumar Kaushal, sir. Dr. Rajesh Kumar Kaushal completed his PhD in Computer Science from Chitkara University, Punjab. He is presently working as professor at Chitkara University, Punjab. His area of expertise is Internet of Things and blockchain. He has published more than 50 patents, out of which 12 have been granted. He is also a lifetime visiting professor at Kazakhstan University, Thailand. He is actively engaged in research activities and presently working on 3 DST-funded projects, namely Smart and Portable Intensive Care Unit funded by Millennium Alliance and FICCI. Remote Vital Information and Surveillance Systems for Elderly and Disabled Persons funded under Technology Intervention of Disabled and Elderly TIDE scheme of Ministry Science and Technology, Government of India. Science, Technology and Innovation Hub at Chitkara University funded by DST, Government of India. Sir received Teacher Excellence Award consecutively in the year 2017 and 2019 by Chitkara University. With this brief introduction, I once again welcome you, sir.
Yeah, thank you very much, ma'am.
This session is.
Thank you very much for. Yeah. Can we start now?
Yes, sir. Yes, sir. You can start.
Yeah, thank you very much, ma'am, for the introduction. So as you know that it's a 5-day workshop on a blockchain system and blockchain networks, and you might have already discussed a lot on this particular technology right now. Okay, so first, before I start my presentation, I would like to share that how I have organized my presentation. So that is very, very important. So I will start my presentation with the blockchain fundamentals first, right? So this is very, very important aspect. And then I will gradually move towards the blockchain frameworks, because we know that the blockchain technology itself is very, very important. And at present in the market, we have lot of blockchain frameworks which are very, very useful, and even industry people are using that framework, right? And once I covered my presentation on blockchain frameworks, once I have a very comprehensive discussion on that, then I will start moving towards the Hyperledger Fabric, which is the most important blockchain framework, and it is very, very important. So, and it is a key highlight of this presentation, that how can you start working with the Hyperledger Fabric, and how can you install it on your machines. So I will be giving a very comprehensive idea about how this installation will work, what will be the prerequisites, and what kind of server do you need. So this is how I will be giving my presentation. So let me first start sharing my desktop with all of you. So let me just give me 1 minute. I hope my screen is now visible.
Yes, sir. Yes, sir. Screen is visible.
Okay. So can you see my presentation, my PPT?
Yes, sir.
Okay, fine. So first I will start working with the concept of blockchain. So usually people when start working on this concept, or whenever you think on this concept, they think it very different, you know. So maybe you have heard about a lot about this blockchain technology when 2 years back or 3 years back you heard a concept of these cryptocurrencies. Even on the news channels you have heard a lot about this particular term. But there is a myth, there is a very a confusion that whether these cryptocurrencies and this blockchain, is it the same thing or it's a different thing. So I would like to clarify this thing that misconception people have. So they believe that they both are exactly same thing. But when you cryptocurrency, you know that this is technology which is working on the blockchain system. So blockchain is an underlying technology which is actually allowing these cryptocurrencies to work properly. For example, when you go to a bank, so you know that in bank when you deposit some money, when you withdraw some money, so they maintain a ledger. So that ledger is very, very important. So similarly, when these cryptocurrencies, they exchange Bitcoins or maybe Ethereum coin or maybe some other coin, they want to maintain some ledger. Who is owning the coin? What is your balance, right? So how these cryptocurrencies can maintain the to maintain a ledger, they people need a blockchain technology. So blockchain is actually a chain of blocks where you people can maintain a ledger so that proper information can be retrieved or it can be stored. And you know that blockchain is very popular because the ledger that you maintain on the blockchain is immutable. So when I say immutable, it means it cannot be tampered by anyone. And there is a feature of auditability. So you can audit your ledger at any time, right? So let's see how it looks like. So when we
Sir, we are not able to hear you, sir. Rajesh, sir?
Am I audible now?
Yeah, sir. Yeah, sir.
Okay. So now you can see that in this blockchain system, so we have these key terms like consensus protocol, hash cryptography, immutable ledger, distributed peer-to-peer network, and the concept of mining, right? So if I talk about a consensus protocol, we know that every time whenever you make a transaction on a system, so that transaction must be verified by all the computers on a distributed network. So during that, we need a consensus protocol or a consensus from all the neighbors so that we can add that transaction on a blockchain system. And the second thing is hash cryptography. And we know that each block is having their unique address, and that unique address is known as a hash cryptography or a hash of a particular block. And in case of a blockchain system, we all know that the cryptography that is being used is SHA-256. It's a SHA-256 algorithm which actually calculates the hash of every block. And when I say how can we calculate that hash, so each block is having a particular structure. So in every block there is a block number, then we have a transactions, then we have a previous hash, we have a nonce value. So I will be covering all that in the coming slides. So if you compute all those, if you input all those to a SHA-256 algorithm, you will get a unique hash number, and that hash will be given to a particular block. And if you talk about immutable ledger, which is again important concept, we know that in case of a blockchain system, your ledger cannot be tampered by anyone, because the reason is this hash cryptography. If let's say if I am on a block number 2, and if somebody try to tamper this block number 2, right, what will happen? The hash of this block number 2 will be changed. And if the hash of this block will be changed, what will happen? This particular chain, it will be damaged automatically. Now the block number 3 will stop recognizing the block number 2, because block number 3 is connected with the block number 2 using the previous hash. Now the previous hash is changed, so I cannot recognize who is the block number 2. So this chain will be automatically damaged, right? And it will be notified to the neighbor computers, and this is how this network works. That is why we are saying that blockchain always maintain an immutable ledger. Then there's the concept of distributed peer-to-peer network. So again, we know that blockchain is not, we are not talking about a centralized system or a centralized computer. We are talking about a distributed network where we have hundreds of thousands of participants, right? Where every participant is playing an important role. So if I say that we have this ledger, like we have a ledger of 1, 2, and 3. So this ledger is being maintained by every single participant on the blockchain network, right? So even if a person is able to tamper, I mean is able to make changes in one computer, then still 99% computers will say that we have an exact copy of this blockchain system, right? And they will automatically share their exact copy with the neighbor, and this is how this blockchain ledger will be updated. And then there is the concept of mining. Last concept is mining. And we know that why people are very interested in blockchain mining, or this kind of thing, because whenever they mine a particular block, they are getting a reward money. And this reward money is usually in the form of bitcoins, if I talk about in the context of cryptocurrency, right? But believe me, if you are making your own blockchain system, the question is, do we need a mining process? Because we all know that this mining process is wasting huge energy, huge electricity. So believe me, when you people are making your own blockchain system, you have to decide, should I go for a mining process or not? I can skip this mining process for my application. It depends on application to application. Do you need this mining or not? And I will be covering this in my upcoming slides also, when I share that how can you install a Hyperledger Fabric. Because in Hyperledger Fabric, I will be giving you one example where I do not need a mining process. So I can avoid wastage of time and wastage of energy, right? So this is SHA-256 cryptography. So this is what we are talking about. So like we know that every person is having a very unique thumb expression. Similarly, digital documents, how can you have a unique number or a unique expression? So what we can do, to your electronic documents, PDF documents, or maybe Word files or Excel files, you can give a unique number, and that number can be a SHA-256 cryptography hash, right? So this is again similar to a thumb expression, and you know that once you give an input to a SHA-256 algorithm, it will always give you a unique number, right? And usually it's a 64 character string, right? And one more important thing is, if you really want to play with SHA-256, how it works, how can you give an input, and how it can be converted to a particular hash or a in the form of a hash system. So you can visit this link. Let me open this link for you. So when you go to this link, you can see some interesting stuff there. So I will be opening this in my browser. So this is a very good tool to play with the hash cryptography. So let's say if I write here hello. Now when I say hello, you can see that the corresponding SHA-256 hash is already ready for you. So this is a online tool where you can give some input and you can see that how your hash is working. And one more important concept is this SHA-256 algorithm is very smart. Even if you make a very minor change, let's say if I add a single dot or a full stop at the end of hello, then your hash is again totally changed. If you make a very minor change, your hash will be automatically changed. This is what I am talking about. So similarly, the same is the concept with the blockchain ledger. So when you have a ledger, if somehow a party is going to temper a block, then immediately the hash will be changed and it will be automatically captured by the neighbors, right? So this is what I'm talking about. If you want, you can use this tool to play with this SHA-256 hash system. So how this SHA-256 algorithm needs what kind of things? So what are the properties of this SHA-256 algorithm? So it is always one way. It means you can convert your text into a SHA-256 hash, but you cannot convert SHA-256 hash into a text. So vice versa is not possible, right? This is the number one thing. And second thing is it is deterministic. Deterministic in the sense that if I input hello, so I will get a hash, right? So if I again input the same text, hello, I will get a same hash, right? So if for every same input, you will get a same hash, right? And the next thing is it is designed in such a way that its computation is very fast, because we are working in a real-time environment. If I talk in the context of Bitcoin and these cryptocurrencies, you know that every single second the transactions are being made by the people. So we need a fast computation, so which SHA-256 is already providing. And the next thing is the avalanche effect, which I have just demonstrated by opening that link in the browser. So avalanche effect means even if you make a minor change in your text, like if you add a full stop or a dot at the end of your text, your SHA-256 hash will be entirely changed. It will be completely changed by just adding a single dot, right? So let's take an example of a traditional ledger and a blockchain ledger. So try to understand that why do we need this blockchain ledger? Why can't we work with the traditional ledger, right? So there might be some issues with the traditional ledger. Na? That is why we people are using a blockchain ledger. So what is the issue with the traditional ledger? I'm giving you one example. Let's say you are buying a home, right? So when you buy a home, so you go to court and a deed is signed and you submit some documents in the court, right? Now, where those documents are stored, where those documents are available. Usually these documents are available on a centralized system, on a single computer, right? Let's imagine that if somehow somebody make changes in your document, in your deed document or in your home registry, and now that home is not owned by you. Now somebody else is the owner of your home, and even you do not know that what is happening. So maybe at some time you know that now you are not the owner of this home because somebody has made changes in your documents, right? So now you will file a case, you will go to the court. Maybe it will take 5 years or 10 years in the court, and finally it maybe or may not you win the case, right? So that's the issue, because everything is available on a centralized system and anybody can temper it. Even a person who is insider, who is a government official, he can make changes in the document, right? So we want to avoid all this kind of things. We do not want this thing. So we want that there must be some kind of ledger where nobody can make a change, right? So that is why we have a blockchain ledger, which is immutable in ledger. So let's say I am giving one example here. Let's say it's a big chain of ledger where we are storing deeds or maybe home registries. So this is the first block, second block, and so on. And now you can see some red blocks at the end. So I am assuming that somebody make changes in this block, right? You can see my mouse cursor. So somebody is able to make changes in this block. Now what will happen? The hash of this block will be changed, right? And now the subsequent blocks, this block, the second last block and the last block, they stop recognizing this block, right? Because the previous hash is changed, and this information will be automatically detected by the peer or the system, and the computers on the distributed network, they will start communicating with each other that now the ledger on this particular machine is not or in a particular state, it is tempered. So they will start exchanging some information, and they will give a exact copy of ledger to the neighbor. So this is how this system is working. So this is the distributed peer-to-peer network. You can see where every single PC, it is a participant in a blockchain system, right? And every single computer is maintaining a copy of a same ledger. Now you will be surprised that why every computer is maintaining a exact copy of a ledger, because this is how a blockchain system works, right? So let's say your entire ledger is of 100 MB. So every computer is storing a ledger of 100 MB locally, right? So if I have to add a new block, let's say, please keep looking at my cursor. If I have to add a new block like this particular block, so same block will be shared with every neighbor. Now you can see these arrows. So this new block is being added into every single PC, which is the participant in a distributed peer-to-peer network. So it means every computer is maintaining a same copy of the ledger. If somehow one computer is the data or a ledger on one computer is compromised, then still the remaining computers know that what is the exact copy, and they will share their copy with the neighbor, and the data will be exchanged. See, this is another example here. So we are saying that we are assuming that where this red symbol is here, red arrow, so this particular block is being tempered, let's say, maybe somehow. And then what will happen? This chain is now not eligible. This is a tempered chain. So again, this information will be received to the neighbors automatically, and they will share their copy of ledger with the neighbor. So again, you can see that all these subsequent blocks, they stop recognizing the previous block. So this is what I am illustrating in this picture. Now, the most important thing. Now we know that there is a mining process in a blockchain system. Now this mining process is very, very interesting, right? So I am going to explain it. So you can visualize this as a structure of your blockchain, right? We know that in blockchain system we have a blocks. So every block is having a structure. Just like if you know that in a computer networks, we have a packets. These packets travel on a cable or maybe on a wireless media, right? And every packet is having start of frame, end of frame, then the data part, then some bits and all that. Similarly, in a blockchain system, we have a block where every block is distributed into some particular fields. The first field is the block number, which is the number of the block. Then we have a nonce value. I will be very soon covering what is this nonce value. And then we have a data part. In the data part, we have a transactions. Then we have a previous hash. And at last, we have a hash of this particular block. Now, how this hash will be calculated? Look at the last hash value. A2, B5, C4, A5, 6A, D3, 15, and F7. The last hash. If you input everything to SHA-256 algorithm, like if you input this block number, the nonce value, the data part, and the previous hash. If you input all these four values to the SHA-256 algorithm, you will get a new hash, and that will be the hash of your block, right? So what SHA-256 algorithm is requiring, it is requiring everything, the block number, the nonce value, the data part, and the previous hash part. So automatically it will give you a hash of your block. Now the next thing is, what is this hash number? So we are already know that it's a 64 letter number, and when we are talking about this hash system, so you will get a 64 letter hexadecimal number, right? If you multiply 64 by 4, because every single digit is supporting 4 bits, you will get a 64 by 4 into you will get 256, right? Now, what is important in blockchain mining? So when we start working in this direction, So if you ever heard about Bitcoin mining, so why miners are mining and what they are mining? They are mining a hash which exactly starts with predefined number of leading zeros. So this is very important. You cannot say that every hash is a golden hash, because you know that in the case of a mining process, every miner tries to find a golden hash. Now what is a golden hash? Golden hash always begins with the predefined number of leading zeros. Like in case, you can, if you look at the third hash number, it starts with some leading zeros. These leading zeros may be 18, maybe 15, maybe 19. It is predefined in a Bitcoin algorithm. I think right now it's 21 or 23 leading zeros. So you have to, as a miner, you have to find out a hash which exactly starts with predefined number of leading zeros. How can you do it? So there is no mathematical way, no technique to find out the exact hash that begins with predefined number of leading zeros, right? So there is only one way. Keep trying, which is like a brute force. You start with the first hash. If it is not exactly that, you compute a second hash, third hash, and keep computing hash value unless and until you find a hash which exactly starts with the predefined number of leading zeros. So that is a golden hash. If you find that golden hash, only that you will be rewarded with the money or with a Bitcoin. So let's take another example here. So you know that if I add more number of leading zeros, then the probability of finding a golden hash is less. If the number of leading zeros are less, then the probability of finding a golden hash is more, right? So you can assume, you can take this box as an example, and you can see that because I am using, I think, 19 leading zeros, so the probability of finding a golden hash is this particular portion, the last one, where you can see this red arrow. So there is only this probability. You will find a golden hash somewhere here, not on the upper side, right? So let's take example with a block. So let's say you have a block number 3, right? This is your present block number, and then you have a nonce value 23. Now what is a nonce value? So nonce value is usually a 32-bit number which you can change to find a new hash. Let's say you start with a nonce value 1. When you take a nonce value 1 and block number 3, then a data part and the previous hash, if you input all this to a SHA-256, you will get a hash value, right? If this hash doesn't begins with predefined number of leading zeros, you will change the nonce value. Now this time you can say that now the nonce value is 2. Again, you take nonce value 2 along with the block number 3, along with the data part, along with the previous hash, and again find a hash. Again, if this time you are not able to find out a golden hash, then again change the nonce value. So this is how you can do. This is what miners are doing every day, right? They are doing, they are trying to find a golden hash, but they do not know what should be the nonce value, right? So let's move here. So now you can see if the number is 23. So again, I am not going to have a golden hash. So my number is somewhere on the upper side, right? So let's say I try a nonce value 21. So when I try a nonce value 21, I got a hash which is again somewhere on the upper side, right? Now let's say I try a nonce value 5012, right? When I try this nonce value, you can see the hash. I got a hash which exactly begins with the 4 leading zeros. So I am taking an example of 4 leading zeros. Now this hash is a golden hash, right? Now you can circulate or broadcast in a blockchain network that I have found a golden hash. So I want to add this block into the blockchain ledger. And if you are able to successful add it, then you will get a reward money, right? So it's all about this nonce value 5012 and so on, right? So this is the same thing. Okay, now if you want to see the blocks, so what kind of blocks are there, and what is the present block on a blockchain system, so you can visit this website blockchain.com explorer, and you will find lot of information over there. So what is the latest block being added on a blockchain network? So this is a very important or a very good website. One another thing is, as I am talking that this nonce value is very important. So, and it's a 32-bit number, and in a 32-bit number, the maximum number that can be available is approximate 4 billion combinations. Right? You start with the value 1, then you start with the value 2, 3, 4, and so on. And this is how you will try 4 billion combination to find a golden hash. And if you are lucky, you will get a golden hash very soon. If you are not lucky, so you have to try every number, right? And now again there is no guarantee that even if you try all the 4 billion combinations, you may or may not get a golden hash. There is no guarantee for this, right? If you even try all the 4 billion combinations, so we cannot say that you will definitely find a golden hash. It may be or may not be, right? So let's assume that I am a miner and I have tried all the 4 billion combinations. Now what should I do now? So how can I find out a new hash? I have already tried all the 4 billion combinations. Then the blockchain system is or a Bitcoin system is providing you another important aspect, which is the timestamp value. So look at this block structure. It is having a block number, a timestamp value, then the nonce value, then the data part, and the previous hash. Now if you input all this, you will get a hash, right? So this is a new block, a new part here, timestamp. So look at this Unix timestamp. It's actually a Unix timestamp which can be added in a block. And right now its value is 244, right? It is in seconds, right? 244. When the time is 244, you have to try all the 4 billion combinations within 1 second. If in that 1 second you can try all the 4 billion combinations and somehow you are able to find a golden hash, then you will get a reward money, right? Now if you are not able to find out a golden hash in that particular 1 second, then what will happen? You have to try the next 4 billion combinations in the another second. For example, this right now the timestamp is 244 and I am trying all the 4 billion combinations in the nonce field, and this timer is also working. You can see we have only 1 second to try all the 4 billion combinations, right? And in that time I have to find out this number, golden hash. If somehow I am not able to find out, don't worry, in the next second when it becomes 245, you can try another 4 billion combinations. See here, when this number is 245, again it's a new second, and in that 1 second again you can try these 4 billion combinations. And because this number is different, 245, you will always get new hash, right? It is not like because if every time you give a same input, you will get a same hash value. Because here the timestamp values change, now you will not get a same hash value, right? Because it's now 2456, 245. And next time when you have 246, again it's a new value, and if you combine it with block number, nonce, and data part, again you will start getting new hash values, right? This is how this mining process works. And believe me, this mining process consumes huge electricity. Maybe on news channels you have heard a lot about that China stopped Bitcoin mining in their country, right? Because they were these miners or a mining companies, they were consuming too much energy, which is not good for a nation. So it's not an energy efficient system. So that is why I'm telling you. So whenever you try to propose any blockchain system, you have to decide, should I go for a mining process? Because I know that I personally know most of the blockchain systems where there is no mining process. We can make a blockchain system where there is a no mining process, right? So this is another snapshot of that. Okay, so now I will be talking on this smart contracts, like what are smart contracts and what you can do, and how they are important in the blockchain system. So you maybe you have heard a lot about Ethereum, and you know that Ethereum is very popular for these smart contracts. And maybe some of you may have tried to create their own smart contracts, right?
So smart contract is a kind of a very small program that you can store on a blockchain system in the blocks, and this is a specialized program, right? A very smart program. That is why it's a smart contract. And this smart contract will find out that when you met all the conditions, like for example, we are talking about some deed system, and for that particular deed we need some documents. So when you uh, provide all those documents on the network on a blockchain system, smart contract will automatically find out that all the required documents have been submitted, and the deed can be done. So it will automatically perform the deed, right? So this is the idea of smart contract. So you can even write your own smart contracts in the blocks, right? And the most popular framework for this thing is Ethereum. So you can try some softwares like Truffle, Ganache, or maybe MetaMask. So you may have heard about all these tools. Like you can use MetaMask and you can plug in into your browser. So when you make your MetaMask login, so you will get some Ethereums, a free Ethereums, which is a simulated kind of environment. And every time you do some transaction on this kind of system, this smart contract system, so some gas charges will be deducted. So you can test your network on this kind of things. So I'm just guiding you that what you need for this kind of system. You can go and start working with MetaMask, Truffle, and Ganache. So these are the tools which can be utilized for making smart contracts on an Ethereum platform. So this can be done. Now, if you want some real examples that how this blockchain system works, and what are the application areas of this blockchain system, then you can visit these two websites. So one is the provenance.org. So here you can find the case studies, right? And second is mediacenter.ibm.com. Here again, you will get a lot of information on the blockchain system, and they are actually real examples. So when you read out all these examples, you will come up with new ideas, and you can think on that how you can provide your own blockchain solution for a real-time problem. So I suggest all of you, so you can take a snapshot of this if you really want to read all these case studies. These are very important. Okay, the next thing is why do we need to add these smart contracts on a blockchain system, and how they are beneficial from a traditional contracts, right? The first thing is because these are the few parameters. The number one is the time. So we can say that when you work with the traditional contracts, so you take a lot of time, maybe some days. But when you are working with a smart contract, so it can be done in few minutes. So that is very time time efficient. And the second is in case of a traditional contract, you always need a middleman. This is required. This is obviously required. And in case of smart contract, it's a specialized program, so you do not need a middleman. So you do not need to pay anything to the middleman, right? And the cost associated with the traditional contract, again, it's very high as compared to smart contracts. And in case of the next parameter, which is the physical presence, so obviously in case of a traditional contracts, your physical presence is required, which is the most important thing. And but in case of a smart contract, your physical presence is not required. So you will be uploading a lot of documents on your blockchain system. You may have your own blockchain wallet. So you log in into your blockchain wallet, you upload some documents. So your smart contract will automatically identify that what is remaining or what has happened, and accordingly your contract will be done automatically. So in case of a traditional contract, again, we need a lot of paperwork, but in case of smart contract, obviously it's a electronic form, right? So we do not need a lot of papers. So in sometimes, and in case of a traditional contract, again, we need a lawyer, right? But in smart contract, we do not need such kind of thing, or maybe a very less, you can say, maybe once the deed is finalized, or maybe something like that. So in case of a traditional contract, we may have mistakes in the contract because human engagement is there. there might be some person who is making your contract, and he may do some errors, so that is the problem. But in case of smart contract, we know that it's a specialized program, right? So the chances of error are very less, almost none, I can say. So again, the last, which is a very important aspect, the security. So in case of a traditional contract, so most of the things are centralized. So which is a problem. We know that if that centralized system is compromised, so you may lose your data, or maybe your data may be tampered. But in case of a smart contract, the entire system is on a decentralized network, and even if one PC is compromised, so there is no issue. We can still continue, and there will be no damage. So for what applications you can use this smart contract? So there might be some very popular application areas. So we can start working with the healthcare industry, so to keep the patient's medical records, right? And we can buy and use it for buying and selling property. We can use it for the insurance, to process claims faster, like see the here. In case of insurance, we are saying that the claims can be done very fast and prevent faulty claims. So if you upload all the documents, all the hospital particular treatment documents, your smart contractor will identify each and everything automatically, and your claim will be done automatically, or it may be passed automatically at least. Similarly, for the voting systems, we can prevent massive election expenditures and restrict voting scams. That is very important. And very good example is supply chain system. You know that the best use case of blockchain is a supply chain system. And if you remember that recently I have shared one a link with you, that is a provenance.org website. If you go there, you will find lot of supply chain examples over there. So that is a very good website. And similarly, if you want to track donations, so that to avoid the misuse of donations, you can go and start making a smart contract, and you can go for a blockchain application. And we can also use these blockchain or smart contract systems for Internet of Things. So a lot of studies are there who are using these Internet of Things applications on a blockchain system, which is very important here, because IoT devices also need a security, right? So then we have a vehicle leasing sales, the will management, online gambling, and the lottery systems. So there again you need a kind of ledger, so proper ledger. So there you can also use this smart contract. Now the most important part of this presentation, and this is what I want to convey all of you, that rather than writing your own blockchain system or writing some code from scratch, so I recommend that you should use these blockchain frameworks. Install these blockchain frameworks on your machine and start working on that. So that is more recommendable, because these frameworks are having lot of features which as a programmer we cannot provide. So this is what I personally feel, and because I am working on this blockchain systems for a long time, so I know that it is very difficult to create your own blockchain system or a blockchain network from scratch. So some people are using Python language or some other languages to make these systems. So it's better you go and install these blockchain frameworks on your machine and start working on that. So now if you look at this diagram, so we have a lot of frameworks here like Hyperledger Fabric, Iroha, Subtut, and Quorum, RT Corda, and Ethereum, right? So these are all frameworks, and every framework is having their own properties, on uniqueness. So before you start working on a particular framework, you should at least know that what is the use case of this particular blockchain framework. So let me show you one website here, so where you can go and find out this information. So this website is hyperledger.org, hyperledger.org/use. This is the official website. If you go to this website, you can find a lot of information like these are the graduated hyperledger projects. You can see the word here, the graduated hyperledger projects. It means they are tested now and they are very, very popular. So first is the Hyperledger Fabric, Hyperledger Aries, Hyperledger Besu, Hyperledger Fabric, right, again, and the substitute Hyperledger Iroha, Hyperledger Indy. So if you click on that particular icon, you will find a use cases and how to install this particular framework on your machine. So each and every information is available on this particular platform. So please do note this website hyperledger.org/use. There you can find out this information. So if you look at the bottom section, so they are saying that these are incubating hyperledger projects. It means they are not properly tested now. They are still in incubation, right? Once they are graduated, they will be in this section, in the graduated hyperledger projects, right? So in this presentation, I will be sharing that what Hyperledger Fabric is all about and how can we use it, right? This is the agenda. This is the key highlight of this presentation. So I will be sharing it right now. So let me go back to my presentation again. Now the first thing is the important thing is, why should I use Hyperledger Fabric, right? So let me go back here. Okay, why I'm choosing Hyperledger Fabric? See, when you are providing a blockchain solution to some organization, maybe to third party, the performance of your system does matter, right? When I talk about the performance of your system, we are talking about the throughput and latency. So these are the two words which are very, very important. So what is the throughput and what is the latency? So we should provide a kind of solution where the latency is less and the throughput is high. So that is why I am saying that if you compare all these frameworks, you will find out that Hyperledger Fabric is having the lesser latency and higher throughput. That is why I preferred this Hyperledger Fabric, right? So let me show you some performance metrics. These are few studies that I have recently reviewed on, from some published papers. Now, if you look at, if you compare the Ethereum and Hyperledger Fabric, so these are the two most important framework, right? If you compare their performance, you will find out that the latency of Hyperledger Fabric, it is much lower as compared to Ethereum, right? So we can, as the number of transactions are getting on a network, so this latency usually increases. But in case of a Hyperledger Fabric, you will get a better performance. And similarly, when you add more nodes on a Hyperledger Fabric, right, more systems. So what will happen again? There is an effect on a latency. So see, even if you add more number of computers, more number of nodes on a Hyperledger Fabric, your latency is still below the Ethereum, right? So that is why I'm saying Hyperledger Fabric is the best. And similarly, these are more studies where we are comparing Hyperledger Fabric, Hyperledger Iroha, Hyperledger Substitute. And again, you will find out that Hyperledger Fabric is having a low latency and high throughput, right? So these two parameters are very, very important. So we cannot compromise with these two parameters. So that is why, so before making your choice, do compare the performance of all the these frameworks, and then decide that should you go with the Hyperledger Fabric or some other fabric or some other framework. Now, how Hyperledger Fabric works? This is the very important thing. So first, we should know that what are the key components of a Hyperledger Fabric. The first most component is peers, because whenever you make a network, you need a peers. And obviously, these peers are part of some organization. So second thing is organization, because peers are not, they must be associated with some organization. And then we need a channel. A channel is a kind of, you can say, a medium where you can travel your transactions. and then we have a chain code. Now, what is the chain code here? Chain code is actually your blockchain ledger, or you can say a smart contract. So chain code represents your smart contract and to maintain a blockchain ledger. Then we need an orderer, and orderer is a kind of organization which actually allows generation of blocks, right? And at last we have a certificate authority. Now, what is the responsibility of a certificate authority? Because Hyperledger Fabric is a consortium, blockchain, or you can say it is not a public blockchain actually. So to add any organization or to add any peer on the network, we need a certificate. So without permission, you cannot add peers or you cannot add organizations. You need a certificate from an organization or a certificate from an authority. So certificate authority is a component which issues certificates to the peers and organizations so that they can be added into a blockchain network. So here I am giving you one example here. Let me share this example here. Am I audible?
Yes, sir, you're audible.
Okay. So let's look at this scenario here. So this is a scenario which I am sharing here so that you can design your own Hyperledger Fabric scenario. So what we can do is, so look at these components that I have just shared. These, let me share. Like these peers, organizations, channels, chain code, order, and certificate authority. On the top, you can see we have multiple order. They may be multiple order or may not be. Even I can make my own scenario with the help of only single order. And then we can have these peers. And these peers are part of an organization. So you can assume that this pink box, it is the organization 1. And this gray box, it is the organization 2, right? And all these components like orderer, organization 1, organization 2, and peers, they are part of this channel. Like we have one channel here. You can see this thin line here. So this channel is very, very important because actually your blocks or transactions, they will be communicating over this particular channel. And then we have a client application because you need some interface or some application from where you can initiate your transaction. So I will be initiating my transactions from the client application. And as far as the client application is concerned, it can be a Node.js application or maybe a React application or maybe some in other language you can make your front end, right? At backend, you will be working with this Hyperledger Fabric, okay? And see this, this symbol here. You can see my mouse cursor here. This is actually a smart contract. So I'm representing this smart contract or a chain code here. So they both are same thing. A chain code and a smart contract is exactly same thing. So you need to install this chain code on the peers as well as on the chain code. It is important. So your channel must have a chain code. Your peers must have a chain code. Your organization must have a same chain code or a same smart contract. And then you can add all these peers and all that, right? So let's take an example that how this Hyperledger Fabric scenario will work. So this is very, very important here. So let's say we have some ledger on the organizations, and every peer is holding a same copy of the ledger. Like you can see that in the organization 1, we have 2 peers. The first peer is holding a ledger where the Alice is holding 15 coins and Bob is holding 8 coins, right? Again, if you look at all the ledgers, they are exactly same because every peer is maintaining a same copy of the ledger. So the values are also same on every ledger. Like Alice is having 15 coins and Bob is having 8 coins, right? Now let's say we want to make a new transaction and we are saying that Alice wants to transfer 2 coins to a Bob. So how can we initiate or how can we visualize this scenario in a Hyperledger Fabric, right? Let's see this. What will happen first? So you will start or initiate your transaction from the client or your front end. And a proposal of this transaction, like Alice wants to transfer 2 coins to Bob, this proposal will be sent to the peers, right? So peer 1 of organization 1, peer 2 of organization 1. Similarly, peer 3, or you can say peer 1 of organization 2, or peer 2 or organization 2. So all the 4 peers, they will get this proposal and they will give their answer to the client application, right? And they will be saying that after transferring 2 coins from Alice to Bob, so Alice will have a 13 coins and Bob will have 10 coins. If the answer of every single peer is same, this is very, very important. If the answer of every single peer is same, it means the ledger on every peer is exactly same. Then we can do one thing. We can send this proposal to the orderer. We can tell the orderer that we are getting similar responses from all the peers. So now it's the time to create a block, right? So now orderer is responsible for creating a block, and that block will be transferred to all the peers so that they can add this new block into the blockchain system. See here. So these are the proposals returned by the peer. So look at the mouse cursor here, these green labels, here. So every peer is giving the same response that after this transaction, Alice will have a 13 coins and Bob will have 10 coins, right? So because they all are giving a same response, so now we can transfer this request to the orderer. Now look at this. Now we are transferring this request, this transaction to the orderer. Now again, orderer will check that if everything is okay. So now it can add this transaction into a block, right? See, the orderer just generated a block, and now this new block which is created here, this block will be shared on all the organizations and every peer on the same organization. So if we have 4 peers on 2 organizations, so this block will be broadcasted to every peer on the organization. So that they can have an exact copy of their blockchain ledger on their machine, right? So see here, the same block, it is being dispatched to all the 2 organizations, organization 1 and organization 2. Now it's time for the organizations or the peers to update their ledger or add a new block into the blockchain ledger. So once they add a new blockchain, new ledger, now they will say that Alice is holding 13 coins and Bob is holding 10 coins, right? So they will add this new block on their blockchain ledger. So the blockchain ledger is updated and the same information is available on every single peer, you can see here, right? This is the whole scenario, the exact scenario that what will be done here. So remember the key components here. So you need a client application, you need an orderer, which is actually responsible for generating a block. A peer cannot generate a block. An organization cannot generate a block. So organizations first have to request the orderer that these are our responses. So please go ahead and make a block. And once the block is ready, that block will be broadcasted to all the organizations so that every single peer on an organization can maintain or update the copy of a ledger. So this is how it will work. And the next thing is, if you want to install this Hyperledger Fabric on your machine, what is required? What are the prerequisites, right? So the first thing is we need a curl software, right? And the preferred version is 7.71.1. Then we need a Dockers. You all know that these days this is the kind of virtualization system, right? A very light virtualization system, I can say, where you can add your Docker images, or you can say the concept is containerization. You can in the Docker, and every container is holding some component, right? Some software or maybe some application. So we need a Docker, we need a curl, and for Docker I preferred 20.10.12, right? And we need a Node.js application which is 16.10.0. Even if you have a lower version, maybe 15 or maybe 14, maybe 12, it will work, but do not go below the version 12. If you have Node.js version less than 12, then this Hyperledger Fabric is not going to work for a version 2.3.1. I'm telling you, right? It should be greater than or equal to 12. Then we need a Node package manager, which is a part of which always work with Node.js, and it should be greater than 7. Do not use a Node package manager which is less than 7 version. Then we need a Linux machine, which is I prefer Ubuntu. So even I have installed my Hyperledger Fabric in the university on this 20.04 system. Then we need a Hyperledger Fabric binaries, which is 2.3.1. So this is a stable version. So I am using 2.3.1, but I think upper version are also available. But I think there is no issue with this version. So you can easily go for 2.3.1. Then we need a Fabric certificate authority. We need a Fabric peer. We need a peer orderer, and we need a chain code system. So we need all these softwares on our Linux machine. So first of all, the first most important thing is Ubuntu machine. Once you have a Linux machine, you can install curl, you can install Docker, you can install Node.js, npm, a Fabric certificate authority, Fabric peer, and all that. And even you should not take care of this Fabric CA, Fabric peer, because once you install Hyperledger Fabric binaries, these certificate authority, peer, and orderer, they will be installed automatically on your system, right? The only thing is you must install the Hyperledger Fabric binaries, which you can take from a GitHub also. And I can also share a link for that. So just install it on your machine and it will be done. Now, the next thing is, what steps should I follow, right? So how can I install this curl, Docker, Node.js, npm, and all that? So I will be sharing all the commands with all of you, right? I'm not doing any live installation here because I know that if I stuck somewhere, it simply takes maybe 15 to 20 minutes to debug a problem. So it's a kind of system. Even I have experienced a lot more problems with this kind of system, So I am not doing a live installation. Rather, I am sharing a comprehensive detail of how you can install this Hyperledger Fabric, right? So this is the first slide where I am sharing how you can set up the environment. So to install a curl software, you need to go for sudo apt install git curl, right? And this is how you can install it. And it's a very small package. It will hardly take maybe 10 seconds or 15 seconds for installation. And then we need a Docker. So we can go ahead and we can install a Docker Compose, right? So with a -y plugin, right? And if it is successfully installed, you can go and check the Docker version. If you are not able to see a Docker version, it means there is some error, some issue. So you should again go back and try to read out that error and try to find out that what happens with the Docker Compose, right? And after that, you need to activate your Docker. So first you need to start it with the system utility. So I will start my Docker with the sudo command, and then I will enable this Docker on my Ubuntu machine. And after that, you need to check out the user. For example, my user on my Hyperledger Fabric machine is health. It's a STI health. So if I'm able to see my user, it means there is no issue. Everything is okay, right? If you are not able to see your username on this Ubuntu machine by using this echo command, it again means that the Docker is not enabled on your machine, right? So once it is done, you can go ahead and issue a command docker ps. When you write a docker ps on your Linux machine, you will get some information, some fields over there, right? Some basic information. And after that, we need to install Node.js. So as I said that we need a Node.js version 12, not below 12. So this is a binaries of Node.js application, right? And curl is a kind of software which can allow you to download these binaries on your machine. So that is why initially we have installed this curl software, because it is a kind of get and post environment, right? So I can download this curl, this Node.js binary, right? And then I can update my machine. So this is a very common command on Ubuntu machine, sudo apt update, right? And once the binaries are available on your machine, you can install it by using sudo apt get install Node.js. So by issuing this command, you will come to know that your Node.js is installed on your machine. And if it is installed successfully, what you can do, you can check out the npm version and the node version by issuing these commands, right? If it is 6 or node version 12, if you are able to see these two versions on your machine, it means everything is okay. If you are not able to see the version of your npm or node.js, it means there is some issue, and you have to check out and you have to read out the error messages and try again, right? Then how can you download and install Fabric binaries? Because this is the important thing here, from where you can install the Hyperledger Fabric software, right? So when I say Hyperledger binary, right, Hyperledger Fabric binary, so I am talking about Hyperledger Fabric software, right? So to install it, you can do one thing. First, you can go on a Linux machine and create a new folder. So you can create a folder with the name Fabric, right? And you can go into the Fabric folder. And once you are in a Fabric folder, you can download the Hyperledger Fabric binaries. So you can again use a curl command. So curl, again, I'm telling you, it's a kind of software which allows you to download the softwares from the online resources. And make sure when you are issuing a curl command, you are connected with the internet. This is important because you are actually downloading these binaries from a live, in a live environment. So once that binary is available in your folder, which is a Fabric folder, so now you need to install it, because downloading itself is not sufficient. So downloading means that package is available, but actually you need to install it on the later stage, right? So I can go here. Okay, I can come back again here. So you know that when you install these binaries, what will happen here? So initially you have only one folder, which is a Fabric folder. Now, if you go into the Fabric folder and check out, you will find more folders, right? And the most important is Fabric samples and test network. So these two folders will automatically be part of that Fabric folder. So you go to the Fabric folder, and again, inside the Fabric folder, go to Fabric samples and test network. And under this test network, you will find a Unix or a shell script, which is network.sh, right? So this is a shell script which allows you to install your or create your channel. Initially, I told you that a channel is very, very important. If you remember this slide, so this is a channel. This is a channel here. See here. See my mouse cursor here. This is a channel. So if you want to add all these things, peers and organization and this ledger, you need a channel. So once you install these binaries here, your peers and your organizations, they will be created automatically for you. So in the test network, what happens? They create two organizations and one peer in each organization. That will be created automatically for you. Even the orderer will be created automatically for you. But the only thing which is not created automatically is the channel, right? So you have to make your network up by creating a channel. So this is a command. So you will write network.sh up, create channel, and -c is for giving a channel name. If you do not give a channel name, by default, the name of channel will be my channel. And then you will say -certificate authority. Like you have to create this channel with the help of certificate authority. Because if the certificate authority is not allowing you to create a channel, you cannot create it. This is not possible, right? Once you issue this command, you will see a message channel 1 created and joined. If you find this kind of message, it means now your entire network is up and your channel is created. So to cross check, you can go to the Docker application and you can write docker ps, and you can find out all the information on your machine, that how many peers are online, how many organizations are online, how many channels are online, right? Each and everything information will be available by writing this docker ps command, right? Now the next thing is, now everything is up, my channel is ready, my peers are ready, my order is ready. Now we need to deploy a chain code, which is also known as smart contract, right? Because a chain code or a smart contract is an application which decides what to do and how to do. So this is very, very important. So if you look at your fabric folder. I told you that when you install these fabric binaries like this command, you will find lot of folders in your fabric folder, right? And in that fabric folder, we have two more folders, which is asset transfer basic and chain code JavaScript. Because I am going to develop my chain code or smart contract in Node.js, so I will be choosing chain code JavaScript, because Node.js is also a framework of JavaScript, right? You can go and use Golang. Golang is also very popular. You can choose other languages also. There's a big list of languages, so you have to decide that in which language you are comfortable. So I prefer Node.js because I am comfortable in that, so I will be choosing this chain code JavaScript, right? And when you go to this folder, you have to issue a command npm install. Now when you issue this command, so you will get a complete package of your smart contract, and along with that you need to set some environment variables, which is something like that for the test network. And let me share here. Okay, so once the package is created, which is a chain code package, so what can I do here? So try to issue a peer command, and if it is not available, so please set this path here. So this is a fabric samples path, because when you need to install a chain code, you need this peer command. Without this peer command, you cannot install chain code on the peers or on the organizations. This is very important, right? So it is very important, before issuing this peer command, you need to check out by just writing a peer whether this command is working or not. If it is not working, you have to set this path on your Linux environment, right? And then I will be installing my chain code on my organization, both the organization 1 and organization 2, by issuing this peer lifecycle chain code package, right? And again, I'm using this chain code JavaScript, right? And I'm saying language is Node. See here, language is Node, and I'm giving one label, which is the basic 1.0. You can take any other name here. So it is user defined name actually. And after that, so see, so once it is done, and if I issue this environment sh script, you will be able to switch between the organization 1 and organization 2. So I can switch to organization 1 by simply writing set globals 1. When I write this command on a Unix framework or on a Unix platform, I will be automatically switched to organization 1. And at the bottom, you can see we have a set globals 2 command. So when I say set globals space 2, I will automatically be switched to the organization 2. So first I will be going to the organization 1, and there I will be exporting some system paths, system variables, along with some certificates. And then I will be issuing peer lifecycle chain code install command, so that this smart contract can be installed on the organization 1. I need to repeat this for the organization 2 also. So I will go to the set globals 2, and I will repeat the same command over here. And this is how this particular chain code will be installed on your both organization and both peers, right? And once this chain code is installed on your peers and organization, we need to approve this chain code, because I'm telling you that without certificate authority, you cannot add any component on your blockchain network, especially in the case of Hyperledger Fabric. So what can I do? At the end, we need to issue this peer lifecycle chain code approve for my organization command, which is part of your Hyperledger Fabric. And I will be saying that I need to approve this chain code or a smart contract for both the organization 1 and organization 2. And you know that when we created our channel, we named it as channel 1. So I am using the same name here, channel 1, right? So again, I go to the organization 2 and again issue the same command, because your chain code must be approved for the second organization also. So I'm going there and then I'm ordering the same command. And at last, so which is the most important thing, once you do all this, your entire Hyperledger Fabric network is ready for you. Now, how can you initiate your ledger? Because you know that maybe once your peers are ready, organization is ready, you need to store or you need to initialize your ledger, which is actually a blockchain ledger. So again, if I go to a command-based system, I need a peer chain code invoke system. peer chain code invoke command along with the certificate authority information, and I will be giving some information of my peers. And when you create peers on your Unix environment in a Hyperledger Fabric, actually your peers are having some port numbers. Like your organization 1 peer is available on 704151 port, and your organization 2 peer, it is available on port number 9051 on a local host, because it's a simulated environment. So every peer, every organization will get a this port number along with the local host. And I will be saying I want to initialize my ledger, so my ledger will be automatically initialized, but you will be surprised that what kind of transaction it will done. So these transactions are predefined in your Hyperledger Fabric network, right? Some initial transactions will be done on your Fabric, and if you want to check out that what transactions have been done on your Hyperledger Fabric, you can again issue this command peer chain code query channel number and the basic chain code name, and then I will be passing an argument get all assets. Every transaction is known as asset. So when you say I want all assets, you have to issue this command get all assets, right? By issuing this command, you will get all the assets, all the transactions on your PC. And if you do not want get all assets, you want a particular information, like I want asset number 6. Look at the command number 2. So I can issue asset 6, which is a unique ID of a transaction, a user defined given transaction ID. So when I say I just want to read asset number 6, only one single transaction will be retrieved from the blockchain network, and it will be displayed on your PC, on your machine. Now you will be surprised that should I do all these things on my network? Yes, you have to do it. You have to do all these things, all this installation procedure to start working with the Hyperledger Fabric, right? And you might be surprised that is this the correct way to initialize your ledger and to read and write your transactions? Obviously, we can have a better environment if you can make your front-end application, right? How can you create your front-end application? We have two different choices. Either you go for a Node.js, either you go for a React application. So I'm comfortable in both of these. So I have made my own applications in Node.js. I'm using Node.js for the backend and React.js for the front end. So I can create my wallet or a transaction application in a React.js. So from React.js, you can initiate a transaction. When you initiate a transaction in the Node.js application, at the backend, you will be executing these queries. So you do not need to write these queries again and again. Rather, you can use these queries using a programming, right? This can be done. So this is what you can do. And the most important feature of this Hyperledger Fabric is how will you compute the performance of your network? This is again very, very important. I told you that just installing a blockchain system on your machine is not sufficient if it is not efficient. So we need to compute the performance of the system, and especially we have two important parameters here. One is the latency and one is the throughput. So how can you compute the efficiency of your solution, blockchain solution? So the answer is you can go and install Hyperledger Caliper. So this is a tool which must be installed on your blockchain system on your Ubuntu machine, so that you can compute that what is the latency and what is the throughput. So what kind of tool is this? In Hyperledger Caliper, you can assign the workload for your Hyperledger Fabric network. You can throw hundreds of thousands of transactions from the Hyperledger Caliper to your blockchain network. And once it is done, the Hyperledger Caliper will start finding that how many transactions are successful, how many transactions are failed, how many time is consumed to commit the transaction. And based on that, your latency and throughput will be calculated automatically by the Hyperledger Caliper. So if you want to install it and you want this kind of information or this particular software, how can you install it on your blockchain network? You can find this information on this particular link, hyperledger.github.io Caliper, and you can see the installation procedure. Again, it is not taking too much time. It is very straightforward. And now I will be sharing a last slide of my presentation, that once you compute the hyperledger, the latency and throughput of your network, how the reports looks like. So this is how the report looks like. So hyperledger caliper makes a report at the end of your caliper test, and that report computes the test number, the name, the number of successful transactions, the number of failed transactions, what was the send rate, what was the max delay, minimum delay, average delay, and the throughput automatically, right? And even it also computes the memory usage. Your blockchain solution is consuming how much memory and how much CPU is engaged, CPU utilization by your blockchain solution. So this report will be automatically given by the Hyperledger Caliper. So I do recommend that whenever you offer any blockchain solution, so please do check the performance of your solution, and it can only be done with the Hyperledger Caliper, right? So I do not want to go into, I think, cryptocurrencies and all that. So this is beyond the scope of this presentation. So thank you very much. And if you have any queries, you can ask. Am I audible?
Yeah, sir, you're audible.
Yeah. So this is my contact information. If you have any other query regarding Hyperledger Fabric, or you are really interested to install it on your machines, then please do contact me, or please email me. Or if you want any kind of help to test your blockchain solution in the terms of latency and throughput, I can help you by installing and using and guiding how to use Hyperledger Caliper. And one more thing is, especially I think Shanti Makka ma'am is online.
Yes, sir. Yes, sir.
Yeah, ma'am, if you want a live session on blockchain Hyperledger Fabric installation, so we can plan such kind of session also, where I need multiple Ubuntu machines, a Linux environment, and the participants in the offline session, so that we can install and use this Hyperledger Fabric. If we can plan such, then it is preferred, I think, in an offline session.
Yes, sir, sure, sir. We'll be planning in the next month. Already we had a discussion in this regarding, because we too really wanted to have a practical live sessions. So we'll invite you to our campus, sir.
Yeah, thank you, ma'am. Thank you. Any questions from the audience?
Yes, sir. Good evening, sir. How are you?
Yeah, good evening, sir.
Sir, myself, Dr. Bala from Mysore, Vidyavati College of Engineering, Mysore.
Okay, right. Sir.
Sir, your session was interesting. Right. Sir, how we can deploy smart contracts? So just now you have demonstrated about, Hyperledger.
Yeah.
Through Hyperledger, how we can able to do the transaction through the smart contracts and mining?
So there are two different approach we can follow, and the first approach that I have already discussed, that is in the case of Ethereum. But I am not talking about Ethereum. I am talking about a Hyperledger Fabric, right? So when you go and use this Hyperledger Fabric, let me show you. See, one command here. So see, when we are using this command PR lifecycle chain code query installed, and one more command here. See, this is the command PR lifecycle chain code package. When you install this chain code or a smart contract in a Hyperledger Fabric, you will get a predefined written code in your chain code JavaScript folder. A predefined smart contract code will automatically be written for you. The only thing that you need to do is you need to modify that code. If you are comfortable in Node.js or JavaScript, you can modify that code and make your logics or business logics for your application, and you can do it. That is why I'm recommending that Hyperledger Fabric or using a framework is much convenient rather than writing your own smart contract from scratch. So some predefined code is already there. You need to modify it. So you can check out in the chain code JavaScript folder.
Sir, is there any doubt? Can I contact you personally?
Sir, I have already given my
Yeah. Correct. So can I contact you in future?
Yes, sure, sure. We can collaborate, even work together.
Okay, sir. Fine. Thank you. Thank you,
Yeah,
sir. Thank you.
yeah. Thank you. Yes, any other questions?
Hello. Good evening,
Yeah.
sir.
Yeah, good evening.
Yes, this is Sarita. I'm the MTech pursuing student. Sir, I have one query that if we're implementing Ethereum or using Ethereum, do we need to study about the Solidity language? Is it compulsory?
When I started working with the Ethereum, Ganache, Truffle, and MetaMask, I too started working with the Solidity. But later on, I switched to the Hyperledger Fabric. So I feel that Solidity is the best. That is the best solution. So you can go with Solidity.
Sir, I heard that Solidity learning or hands-on is very difficult as compared to other languages. Is it true or only myth?
No, it is. I think it is not true, because if you go and find the online solutions, you will find that majority of the smart contract Ethereum solutions are on the Solidity only. But you can go and use Node.js also.
Okay, sir. So Node.js is very easy to set implement
Yes,
the contract.
yes. That is why I am also using Node.js.
Okay, thank you so much, sir. Session was
Yeah.
superb, sir. Superb.
Thank you, ma'am. Thank you. Any other queries?
Excuse me, sir. Am I audible? Can you hear me?
You are audible.
Yes, sir. My question is, so the different nodes are there. So different roles, can you assign, like one node will be able to deploy the chain code, another node will be able to execute, like that role based, how to go about, sir, this, assigning different roles to different nodes of Hyperledger Fabric framework, this network.
Can you see this presentation? Is it
Yeah.
visible?
Yes.
So let's say we are having this kind of scenario. So your question is, how can we? Can you repeat your question?
Yeah. Assigning different roles.
Like, what do you mean by role, actually?
A role is the chain code is there. It cannot be deployed by every peer or this one. It can be deployed by certain this, and other peers can execute.
Yeah.
So like that, some role based management.
It can be done. For that, what you need to do is you have to create multiple channels. Let me show you. Let me show you this slide. So now look at this. This is one channel here, and these peers, like two peers on organization 1, 2 peers on organization 2, they are part of this channel, and they are all having a same role. But if you want two other organizations, right, and peers in that organization, and you want a different role, you have to create a new channel, and those peers and those organizations, they must be part of another channel. In a same channel, they all have a same role.
Okay. In a single channel, you cannot just distinguish one node from another.
Hello.
In the same channel, all the peers will be the equal, no? So like you cannot distinguish one from another.
All peers will
separate
have
channel has to be created for that purpose.
Separate channel has to be created for a different role.
Yeah, and this is a permissioned blockchain network, no? So like that, every peer has to authenticate before joining.
Yes, and for that we have a certificate authority, which is a component which is automatically installed on a Hyperledger Fabric.
Okay, so this is something, the X509 certificate of.
Yes, exactly, ma'am, exactly. I think you have worked on this Hyperledger Fabric.
No, just I have heard, but practically the hands-on, this one only theoretically I went through this. But Ethereum very extensively I have worked, and I have also authored 2 books on the blockchain. One is Blockchain Beyond Basics, and another one is all that Ganache, MetaMask, connecting to test networks, Apolia, and everything.
That's great, ma'am. Great.
Okay, sir. Sir, even we would like to have your session, sir. So it was excellent, sir. It's on. Okay, very interesting and very inspiring.
Yeah, thank you very much, ma'am. And I want to convey one message to all the participants. I know that when I started from this slide, so that will be very difficult for the audience to understand. I know this, because I told you in the beginning that when we start installing this kind of framework, or this kind of establishing a network, so we do face a lot of problems, and to find a solution to that problem, sometimes we need 15 minutes or 20 minutes. So this kind of live installation session cannot be done in live platform. So I want some offline sessions for that, so that we can sit together and find out the bug and again resolve it. So that is why I have just shared the commands here. Otherwise, if you want, we can go for an offline session and install this this kind of system.
Even I went for a WSL, that is a subsystem for Linux from Windows. But even that was very slow, and
Right.
it was took a lot of time. So another
And
that Rust language is there. So even that is
yes. Ma'am, it is there are multiple flavors. If you look at your Fabric folder, once you install it, you will find a big list there. Right. It totally depends on in what language you are comfortable.
Yeah,
The language, the particular language is not going to have any impact on the latency and throughput. Believe me. Right.
Yeah. Okay. Yeah,
Your
that's what
business,
I wanted to
yeah,
ask.
yeah.
The
So you can,
performance, it
yeah,
will affect.
sure.
Thank you very much, sir. Thank you.
Yeah, thank you. Any other questions?
Sir, this is Vidya Lakshmi from Plain Technology. May I audible, sir?
Yeah, you are audible.
Sir, is Caliper tool used for any other domain or only for blockchain applications, sir?
Ma'am, can you repeat your question?
Caliper tool.
Caliper tool.
Yes, sir. That tool.
No, I personally believe that Hyperledger Caliper is only used for a Hyperledger Fabric.
No.
Yeah. As per my knowledge, Caliper can only be used for the Hyperledger Fabric only.
Okay, sir. What is the equivalent olden technology for the blockchain, sir?
Actually, I have not worked with the older technology. I always started with the Hyperledger Fabric few years ago. So still I'm working with this. So I have no idea that how can you check out the latency and throughput if you are working in Ethereum or any other framework. So they might have some other solution. And one solution is a Wireshark software. Have you heard about Wireshark?
Yes, sir. Yes, sir.
So you can install a Wireshark software on your machine, which can track every single packet and find out when that packet was traveled, when it was committed, and the gap between that time, you can find out the latency and throughput.
Sir, how we can integrate the blockchain in cloud security, sir?
If you want for a cloud security, you need to check out some online resources I can share, because I never worked on a cloud security. So this is not my domain actually. So if you want, I can share some links with you.
Okay, sir. Is there any meaning in public auditing in blockchain, sir?
Public and?
Public auditing.
Public auditing.
Yes, sir.
So exactly what you are looking for?
In cloud security, we are telling now public auditing, cloud security protocol for privacy preserving, like that.
Ma'am, I'm telling you that I have not worked about this cloud security and all that. So that is not my domain actually. So if you want, I can share some links for that.
Okay, thank you. Thank you.
Any other queries?
Good evening, sir. Sir, this is Ritika. I just wanted to, sir, this is completely, you have guided us with the Ubuntu machine, Linux machine.
Yes.
What if we want to work with Windows?
Yes, we do have a solution for Windows also. So for that, we have a complete different set of commands. So if you want, you can drop your email ID with Dr. Shanti Mishra. We can share that information with you. Even you can install this Hyperledger Fabric on a Mac machine also.
Okay.
So we have, if you go to the if you go to the hyperledger.org website, you will find every details like how to install it on Windows, how to install it on Linux and Mac. So on the hyperledger.org, every information is available there.
Okay, sir. That was only my concern because your session was so good. and I just wanted to start working on blockchain. So I had Windows machines, so I just wanted to clarify that. Thank you, sir.
It will work, ma'am. No problem.
Thank you.
Thank you. Any more queries?
Tejasvi ma'am, I think we can proceed by saying thanks to sir.
Yes, ma'am.
Tejasvi ma'am.
Am I audible?
Yeah, ma'am, please continue.
Yeah, thank you, ma'am. Thank you, sir. I would like to take this opportunity to thank you on behalf of the organizing team for inspiring words. It was obvious that you are extremely knowledgeable in the field of blockchain, blockchain mining, blockchain frameworks, applications of smart contracts in blockchain, working with Hyperledger Fabric and Internet of Things. And I can like this knowledge up to a great presentation style. I find that the whole area of your expertise is truly fascinating and would like to ask you to consider the repeat performance at some future date, sir. Thank you so much, sir. Thank you once again.
Yeah, thank you very much, ma'am. Thanks a lot. Thank you very much.
Over to Shanti, ma'am.
Thank you so much, Dr. Kaushal, for sharing your presentation, as well as even though we had some difficulty at the beginning for joining, but still the session was really, it went very like great, sir. And really, I appreciate the way the practical approach you have given to the audiences. It made us like many concepts clear, sir. And definitely in Vardhaman, we are going to organize your live sessions. Physically, you'll be coming here and you're going to take us this practical approach. But as you have to give us some remote access to your server and all, I guess,
Okay.
that will be having a discussion afterwards. Thank you so much, sir, really, for sharing your experience and the insights about the blockchain technology.
Yeah, thank you very much. I'm Shanti, ma'am, and don't forget to change your password. I'm using your team's username and password.
It's okay, sir. I think you are not harmful. That's the reason immediately I have shared.
Thank you, ma'am. Thank you. Thank you. Bye.
So if we wanted to have one photograph, so that I request all the participants kindly switch on your cameras so that we can take the photograph. I request all the participants kindly please switch on your video so that we can take some screenshots, please. Is it done, Sindhu ma'am? Sindhu ma'am, is it done?
Yeah, ma'am.
Thank you, sir. Thank you so much. Thanks to all the participants for taking part in this workshop on blockchain technology and its applications. You all have been wonderful participants with so much potential and the creativity. It was so good to have you at this event. And tomorrow we have Dr. Vikas Hasija, who has completed a PDF from the National University of Singapore. And he'll be delivering a session on issues with the existing blockchain architectures, way to resolving them, and recent research opportunities in blockchain technology. And tomorrow after the session, we also have the valedictory session by 8:15. We try to wind up the session by 8:15. After that, we have the valedictory, and we are planning to conduct a small quiz just to understand your understanding level only, just to know the understanding level. It is not nothing relevant to your certificate and all, because as we at the beginning in the rules and regulations, we haven't mentioned anything that you need to qualify a certain quiz to get the certificate and all. So that's not meant to anything related with your certificate, only just to understand, know your understanding level of the workshop, what you learned and everything. So there will be 20 questions, and the duration will be, the link will be open for 20 minutes duration. And I wish all of you a very best for your future. And once again, thanks being a part of this event. Have a great time. Good night, guys. Take care.
Shanti ma'am.
Thank you. Yes, sir.
Ma'am, that feedback link was not shared yesterday, no? So today, is there any feedback link?
Yeah, yesterday also it was shared, ma'am.
No, where, madam? In WhatsApp, I could not see that.
It was there in both the WhatsApp groups.
Yesterday you didn't share the feedback link by now.
Sir, it was there in both the like WhatsApp groups as
No,
well.
no,
You can verify in WhatsApp group.